As we shall see, general game playing is an interesting application in its own right. It's intellectually engaging and more than a little fun, but it's much more than that. It serves as an analog for applications of logic in other areas, such as business and law, science and engineering, and other areas. More fundamentally, it raises questions about the nature of intelligence and serves as a laboratory in which to evaluate competing approaches to intelligence. Game descriptions provide full information about a world and determine optimal strategies as a baseline for evaluating agent behavior. By its nature, the general game playing setting can be used to evaluate problem-solving strategies and, by extension, theories of intelligence. But taking into account representation, incompleteness of information, and resource bounds. The idea of using applications like general game playing in such settings for such purposes is not new. It was in 1958 that John McCarthy invented the concept of the advice taker. The idea was simple. He wanted a machine that he could program by description. He would describe the intended environment and the desired goal, and the machine would use that information in determining its behavior. There would be no programming in the traditional sense. McCarthy presented his concept in a paper that has become a classic in the field of AI. Here's a quote. "The main advantage we expect the advice taker to have is that its behavior will be improvable merely by making statements to it, telling it about its environment and what is wanted from it. To make these statements will require little, if any, knowledge of the program or the previous knowledge of the advice taker." It was an ambitious goal, but those were times of high hopes and grand ambitions. The idea caught the imaginations of numerous subsequent researchers, notably Bob Kowalski, the high priest of logic programming, and Ed Feigenbaum, the inventor of knowledge engineering. In a paper written in 1974, Feigenbaum gave his most forceful statement of McCarthy's ideal. The potential use of computers by people to accomplish tasks can be one-dimensionalized into a spectrum representing the nature of instruction that must be given the computer to do its job. Call it the what-to-how spectrum. At one extreme of the spectrum, the user supplies his intelligence to instruct the machine with precision exactly how to do his job step by step. At the other end of the spectrum is the user with his real problem. He aspires to communicate what he wants done without having to lay out in detail all necessary sub-goals for adequate performance. Okay, so one final remark. Some have argued that the way to achieve intelligent behavior is through specialization. That may work so long as the assumptions one makes in building such assumptions are true. For general intelligence, however, general intellectual capabilities are needed, and such systems should be capable of performing well in a wide variety of tasks. To paraphrase the words of Robert Heinlein, a human being should be able to change a diaper, plan an invasion, butcher a hog, con a ship, design a building, write a sonnet, balance accounts, build a wall, set a bone, comfort the dying, take orders, give orders, cooperate, act alone, solve equations, analyze a new problem, pitch manure, program a computer, cook a tasty meal, fight efficiently, die gallantly. Specialization is for insects. Those of us who are more interested in artificial intelligence than artificial insects agree with Heinlein.